Hello, welcome to my Switch stream. I will post. I posted a message earlier about the repository that has all the resources or the examples that we're using. So I'm going to do that again to make sure that this actually arrives. Can see it over here, but hopefully it made it. Going to wait a little bit for a little more people to join. So hey, Ejoreo. Okay, how you doing? A little hard to say that. I believe that's probably not your real name, but who knows? Maybe it is. If you want to let me know where you're from, that'd be cool, because then I know where that name is from. Eric. Haha, okay, Eric, how are you doing? So then I know where you're from. I knew that wasn't your real name. So welcome. So we will start in about, give it 2 more minutes for some people to join. I just tweeted the last tweet to make everyone know that we are on. And let's see. Okay, enough. I need to mute that, otherwise I'll hear myself. I can see here how many people we have. Hey, Bit and Bang, also known as Tierney. How are you doing? So, yeah, this is definitely not showing me the right thing, right? Because if you guys are commenting, then there must be some viewers. So, might be a little delayed here. But let's wait 2 more minutes. In the meantime, I will explain a little bit about async await. So, who in the chat, I don't know how many others are in the chat right now, who in the chat hasn't used like either callbacks or promises? Who is kind of like reading you to this concept in general? So just say something like, so if you haven't used callbacks, just say me at this point. If you haven't used promises, okay. So it seems like all of us are at least versatile with promises. So that is good. So you have not used promises. Okay. So promises are basically a very light wrapper around callbacks. And they tried to solve this problem of error handling. So they did. So just to go back in history a little bit, Node.js did have promises very early on, but not the right ones. They were not that greatly implemented. So then they actually went to callback style, and the callback style was kind of like you had 2 arguments to your callback. So you did an asynchronous operation, you got called back when that operation was done, and the first argument was an error, and the second argument, the actual result. So you would always have to check for the error. If you had an error, then you needed to handle that. You couldn't just keep going. And then most likely also if you had an error, the result was either null or definitely not valid. So then, but then you have to handle that error in every stage, right? So then basically promises came around to make that a little easier. So maybe I'll explain it a little bit with code. So by the way, I just pasted something in the chat. I don't know if this chat is kind of like once you're connecting, if you can see all the messages, but for the ones who just connected, hi Adrian, how you doing? So for the ones who just connected, I'm going to paste this again. This is these are the examples that we're going to use to play around with async await, right? But right now I was talking about promises, so I'm going to show real quick some promises. Okay, yeah, by the way, you see some Spanish there. This is the last day for a while that I'll be streaming from beautiful Medellin, Colombia. Also, if you hear some noise in the background, there are other people in the same house, so that's where that comes from, so don't worry about that. There are no ghosts or anything. But yeah, this will be the last time for a few months, and then I'll be streaming from other places. So yeah, that kind of sucks too, right? The chat doesn't persist. So okay, pasted the link. Yeah, Adrian, sorry, but I'll be back. So pasted the link. Okay, so now we're gonna get to promises. So basically, what you could do with promises is you could say, do something async, and that async thing, assuming that return a promise, you could then do something else async, right? and then and assuming that's also a promise, or you could do it this way to return a promise, and so on. So you could like do this indefinitely. I don't know, either one, and then at the very end you could add a catch. So basically that would then, if you had an error, you could handle the error here. So at least like in all these steps you didn't have to handle the error. Don't want to get too much into detail of promises, but there are also challenges where in some cases you did something and then actually inside, let's say this is like a function, right? You then would do something, you would get some other thing, whatever other thing, and then you would do something else and have another then. So you would still end up with like nested thens if you didn't do it cleanly enough. So, but promises were definitely, from the code perspective, were from the way that syntax looked, the way that error handling worked, kind of a progression. But not everyone was like 100% happy with them, and also like they weren't as optimized yet. So we can't see your code. Your Wesker is covering it. Okay, am I still in? Okay, thank you. I thought I had switched that. Okay, now it should be in this mode. Now you should be seeing it. Thanks for tuning. So what I was saying, I guess we have to go through it again. So you do something async, then you do a then you do another then, and at the very end, I should have minimized it by now. So if it's still not minimized, let me know. But now it looks like, yeah, but now it's minimized. I'm trying to be cool here with my, full screen and whatever. Not working out 100%. But anyway, so promises at least gave you like a global error handler. You only had to attach one error. So, however, originally the promises weren't even part of JavaScript yet. They weren't implemented by the engines. So there were multiple implementations. And also what could happen easily, like you have an unhandled promise and it just like disappears into space. It's really hard to debug. You could end up in weird scenarios. So fortunately now promises are part, when we're talking about Node, they are implemented by V8 proper. They actually create microtasks under the hood. So they're running in their own kind of, you could call it like, their own kind of event loop kind of thing, where they get handled. And debugging has improved immensely. There's still, from a debugging story and a performance story, nothing will beat callbacks still, but promises have improved. So now, but as we saw, this is still not like too great. So then, people thought, well, we can actually put some syntactic sugar on top of these promises. And that's basically what happened. So this is what async await is. So let me go to my summary here. I actually put a summary in here. So basically what you do is you put an async in front of a function, and then you mark it as asynchronous. And so when you mark a function as asynchronous, it will always return a promise, right? So that means that even if you're not doing anything asynchronous in there, the JavaScript runtime will not understand that and will still create a promise. So you have to be careful there. And then it will resolve with the return value. So even if you return a value, and we're going to look at that in a second, it will still then wrap that in a promise because you have an async in front of it. And then await is basically, you could call it syntactic sugar to consume promises, right? It's basically, you could say, instead of calling then, you would call await. And then you don't have to give it a function. We'll look at that in a second also. So basically, then with that syntactic sugar, your code kind of looks synchronous, even though it's actually running asynchronous. And the async await construct, like promises and callbacks, they don't actually block the entire execution of the entire event loop. They kind of, it looks like they're stopped there, but they're kind of just stopped in the function. And we'll look at that also in this, towards the end actually. I'm thinking this will take about 2 hours. So just so people have an idea where we're going. And if you have any questions, please ask. I mean, that's why this is a stream. Otherwise, I could make this like a screencast and put it on YouTube. So yes, it is kind of smooth. I'm assuming you're referring to async await. The code looks better. So let's start. We have a bunch of examples to go through. So let's start with the basics. So here we have 2 functions. Here, this one here has an async keyword in it, but it's actually not doing anything async. And then here we have one that is actually doing something async. So let's look at that a little bit in detail. So what's happening here? We're saying, okay, So first of all, about this task thing, we're going to use it in all the examples. We are not going to look into the implementation at this point because it's a little hard to understand at first. But basically what all the task does is it says, okay, I'm going to return the result that you already give me, which is kind of not how this usually works, right? Usually you would do an asynchronous thing, like you would do a call, let's say to Twitter, give me all the tweets, right? And that would asynchronously complete, and then it would return you the results. Well, to make our lives easier for these examples, we're basically telling the task what result it should return us. And basically what the task is, we're going to look in the task a little more in detail so you don't have to understand it all, but all it does, it creates a promise. And then inside the promise, it creates a timeout. And that timeout then will resolve after however long we told it to wait. So we're kind of simulating asynchronous work here, right? And if we gave it an error, it will resolve with an error. Otherwise, it will resolve, basically reject with an error. Otherwise, it will resolve with a result. So, but you don't have to understand that fully. Just understand that we are basically using the task to, simulate asynchronous operations, right? So as you saw, the task returns a promise. So that means we can await it. So anything that's a promise can be awaited. Even anything with a then inside of it can be awaited. So you can even create this own class with just a then method on it, which I wouldn't necessarily recommend, especially if you're just starting out with this async await. But anything, basically, that's a promise you can await. So what we're doing here, we're calling user JSON, we await. Yeah, performance, we're talking about later, Adrian. That's kind of towards the end, but yeah, that's a good, we should always worry about that, right, when we see something the first time. But yeah, I will address some performance issues later. So we're awaiting this here. So what that means is actually, it looks like we are kind of stopped here. So we're not going to continue to line 14 in this case until this call has completed, meaning that it has been resolved, right? So if you, for instance, were going to Twitter, to the API, that means it would have returned result now. But as we'll see later, the code doesn't really stop there. It just kind of makes it look like it, but other things can still go on in the event loop. And again, we'll look at that in more detail. Now, what is this weird construct here? Well, the thing is that, as I said in the summary, we can only execute await. Well, maybe I didn't say it here, but it's still true. We can only call await, we can only use the keyword await inside of an async function. So for instance, let's just comment this out. If I was going to say await, if I can type today, and we give it some ID, right? Now, even if I save it, the lint already standard, which I'm using, which uses ESLint under the hood, already tells me something is wrong here. Await keyword is reserved. Okay, yeah, but I know it's await, right? Like I'm trying to use it. But the thing is, if I run it, it will be more clear. It's unexpected. It doesn't work. Like you can't use await at this point, kind of on the script level. It has to be wrapped inside a function, and more specifically, it has to be wrapped inside an async function. So this is what this is. This is the shortest way I can write an async function that basically here I'm creating it until here, and then I'm executing it immediately. So it's a self-invoking async function. So now in here, I can do numerous things. I can use await. Well, actually, it should be await, not async. So we'll have to fix that later. Actually, let's do that right now. Well, I didn't change anything else. Called the blooper, because it happened during the stream. So okay, so now what am I doing here? So I'm saying user get user, and down here we're logging it. So let's see what happens now. So you're thinking that might work, right? Well, let's look at it. So if I don't await it, what it does, I hope everyone can see my screen. Actually, I might just push this a little more into the middle of everything because we don't need that much space. So as you can see, it returned a promise. It didn't return me the value. Why? Because I forgot to wait it. So let's just get rid of that. So this is how I should have done it, right? So if I wait it, now it actually what it will do. So before what it returned right away. It returned me, hey, here's your promise. Like it's not resolved yet or anything. It didn't do anything yet, but here it is, right? If I await it, it will actually say, okay, let me run that promise. Let me wait till resolve or reject is called. and handle that. So if resolve is called, I'm just going to return you the value that it resolved with. Otherwise, I'm going to, you're going to have to handle an error, and we're going to get to that in a second as well. So that's kind of cool, right? So here's another example. What if I have this function that's actually synchronous, right? It doesn't even, there's no promise stuff going on in here, right? At least inside the function, right? So what happens here? Well, as we see, it still wraps it in the promise, right? It already knows the value, even though it just put it there, but it still wrapped it. And why does it do it? Because you put an async in front of the function, so it always creates a promise, no matter what. Even if I didn't even use anything async here, but you have now that overhead, and that comes to Adrian's question, that you're still creating a promise. So you have to be careful, right? Because you're going to cause memory overhead, especially later, and also some performance overhead. So this is how we would consume it now, but it's pointless, right? There's no reason why we would have to do that. So this would be the correct way. But now, can we still await this? Yes, we can. So the cool thing is that, so if we don't await it, it works. It returns us the thing. If we do await it, it also works. It returns us the same thing. So that means that you can actually change the API later, kind of. So for instance, if you started out asynchronous and then you realize that it could have been synchronous, you can actually just change it and the awaits will still work. It's a little hacky, but it's kind of cool. So are there any questions so far? You should ask, because we're going to move on to error handling in async await. Okay. So next one, try catch. So the cool thing, I mentioned earlier that with callbacks, we had this style in Node with the error first thing, where you have to check for the error object if it's set, and then you have to do something, and then it doesn't bubble properly, so you have to make sure to handle it on every level. For the promises, it got a little better because you could attach a catch to the end of the promise chain. But then we had like one way of handling errors, like for the asynchronous code, right? And then we had another way for the synchronous code, right? Because as you all know, for synchronous code, like in this case here, I'm doing a JSON parse, right? And whoever followed me, thanks for following me. I can hear that. I get little musical cues that you unfortunately can't hear because I didn't hook up, SoundCloud didn't hook up the music today. But thanks for following me. So JSON.parse, that could throw, right? That's one of the only built-in functions, one of the few in JavaScript that can throw. Well, we have to already put a try catch just for that. Now, if we were using promises or callbacks now for the async stuff, we'd have to have another error handling thing. So the cool thing is about async await that it kind of unifies that. Like we have one way of handling errors now with try catch. So this works magically. So this is a little bit convoluted because what we're doing here, the result, we allow the caller to overwrite the JSON, and we do that to cause an error, right? So yes, yeah. So basically, yes, Eric, so basically we created a function. I mean, we can see it here, right? So you can see that the matching brace there is down there. You see that, right? If I go there, so that completes creating the function. So we create the function first, and then we invoke it right away. That's what that is. I guess I'm getting the chat a little delayed or something, but it's fine. So the JSON parse could throw, so we do it here. Here we allow overriding the JSON so that we can then cause something bad to happen basically here, right? So basically when we parse the overwritten JSON, it's a little convoluted, I admit it. So we overwrite the JSON, then we await the result, which will be either the overwritten JSON, or if we didn't overwrite it, it will be Bob and ID, right? So that will then cause this error. However, we also added a way to, okay, 30 seconds delay, okay, thanks, I'll keep that in mind. So then we also added a way to just cause an error here. Basically what we're doing, we're creating the error and we are passing it into our task. So then the task, the way we did it, it will then just reject that as an error. So that's kind of how we simulate errors actually happening inside the task, right? I mean, that's not how we would normally do it, but this is just to simulate this, right? So now if we run this with username 2, everyone is happy, right? Because it was username 2, no error was created. Now, if we run it with username 1, this will cause like, basically we're assuming that, you know, username, user ID 1 doesn't exist in the database or something, right? So when we get the user and we actually execute the task, inside the task we find out that it's not there, and then the task actually throws an error, and then the promise is rejected somehow, right? That's what we're assuming. So now the cool thing is that error basically gets caught an error, right? This is our line here, right? Caught an error, and it gives us some cool information about where it happened. So it happened inside get user. So that's kind of nice. So at least like we know. So let's look at that line, right? Line 8. So we know exactly where that error was created. Now, obviously, if that error was created inside the task itself, we're getting a proper stack trace. Does that make sense? So because right now the stack trace is attached to where we created the error. So what we actually could do is, let's fix our thing a little bit. So what we actually should do is we should give it this as an error, and then have the actual error created inside the task. So that's what we can do. So we can say if the error is set, right, then we actually here we properly create the error, right? Because now the stack trace is proper, because the stack trace gets created when the error gets created. So that's kind of tricky in JavaScript. So don't like, for instance, create like global errors that you reuse everywhere, because then you use you lose the error stack trace. Okay, so now let's try this again. So now we actually see where it happened, right? It's instead timeout, on timeout, we saw an error happening, which makes perfect sense because that's where it happened. So now I'm going to get a little bit into debuggability already. We're going to just show a little trick that you can do with regard to errors. By the way, the whole point here was that to show that, right, we can use try catch the same way for async code now and for synchronous code. So no matter where the error came from, we'll catch it the same way, which is pretty awesome. Like one way of thinking things, much simpler code, much simpler to understand. So now I'm going to do something where I'm going to show you some debugging. So what I did, I have two things here. One is Budo and one is inspect. So Budo is this cool tool that basically allows us to just run a file. There are others. I think Banka you can do the same thing with. So, oh, by the way, it's Budo. I just saw this. So you can just say Budo this file and open in the browser or something. And the cool thing is that since all the stuff we're using here also is running in the browser, there's no Node.js stuff specific, right? And V8, the V8 that's used in Chrome is actually always almost like a little bit ahead of Node. So it has also async await support. So we can just say npm run Budo. And now how do we pass it an argument? Well, you can actually pass arguments to npm scripts like this. So then we can say run this try catch thing. So now what will happen, Budo will actually serve this file on the localhost. So we can now go here, localhost, I think it's 67. Okay, and so now we got the error, right? So we can now click on here, and now we ended up in the so there are two files here. One is source met, one isn't. So I'm just going to turn that off because that's what I wanted to show. So now what's happening? We put a breakpoint here where our catch is, and now we can kind of see where things happen. We can still get a cool stack, and you wonder how in the world did that work? Because we have async stack traces turned on. So one important thing for anything, Node development, JavaScript front-end development, don't disable async stack traces. Keep them on. So that's how we have async stack traces, because you can still see that we got back here. That's where our error occurred, but before we actually were here, we called that. So we can still kind of see the stacks, but we can even do a little bit better. Thanks for following me. I'm going to switch over who that was. Napcast, thanks for following me. So what we can do, we can say pause on exceptions. And we're also going to say pause on caught exceptions, because that exception will be caught, right? So we pause on caught. Now we're going to break right here where the exception. So somehow V8 knows, oh, look, there's a reject. So and there's a new error created. So somehow it knows that, okay, this is an exception. And the cool thing is now we even have more information. So we see our set timeout here, right? But we also see where our task, where the promise was created. Then we can see actually where we awaited the task, where we basically created that promise that then ended up rejecting. So debuggability has improved a lot. We can do the same thing. We can run it with Node. So basically the other script that I have in here basically all it does, it runs node -" inspect break. What that means, it will launch the debugger and break on the first line and wait for us to attach. Oh no, sorry, it will launch the program, break on the first line, wait for the debugger to attach. So we can invoke that the same way. We'll run inspect, and then we'll pass our file. And now magically, since we have a debugger running, this symbol here appears. So that means we can now actually debug here. Click on that. And now we are in Node. And if we also have pause exception turned on. So now if we break, so this first error is actually caused by Node itself, and it's an expected error somehow, and it's fine. It just because we said, pause on call exceptions. So that's what happens inside Node sometimes, but nothing bad. So now we have even more of a stack trace because obviously there were also some initialization happening, but we could even see where that the timeout was created. We can see kind of here get user await, right? We can go back all the way here, and obviously we see a little different stack trace because a node basically this timeout is actually not part of JavaScript proper. That's actually implemented by the browsers, or in this case, Node had to add its own implementation. So we can see a bunch of stuff, but you can see that this is async, right? And the way this works is they're actually using async hooks under the hood. So if anyone heard about async hooks, actually Trevor Norris, who works with me at NodeSource, he implemented async hooks for us. And DevTools actually uses async hooks to give us these async stack traces. Really, really cool. So anyway, so you kind of see that debugging has gotten a lot better. And I think I haven't played a ton with just promises, but from my understanding is debugging with async await is still easier than with promise. Basically the stack traces that you get make more sense, and then basically where you can hook into your problem makes it easier, right? Any question about that one? There was a lot. That's an important one. That's error handling. That's pretty huge. One way of error handling. That's going to change everything. Makes it. And by the way, if anyone is interested in how async await came about, there was an async await in C#, at least. There might be other languages, but at least I know in C# there was async await. And then actually there were generators in JavaScript that kind of did a similar thing. That it was called yield, but it was a similar idea. But async await kind of put that properly in the language, and it's fully supported, and it just works awesome. So now we're going to jump to kind of techniques. How do I execute? How do I do control flow? We're used to for loops. For each, we're used to map. And we do that with synchronous things, right? Makes sense. It's easy. How do I do this with asynchronous now? And in the callback code, then you'd actually have to, you couldn't put a for loop. It doesn't work like that. You have to do other things. You'd have to kind of do recursive calls. You might have to do counting, to know when you're done. Then there were libraries that helped you make that easier. There was basically the async library that had a bunch of methods on it that made it easier for you to use callbacks to kind of construct a flow. But it's actually, the idea with async await is that you can also use these synchronous constructs now for your async code. First, I'm going to show you, though, things that don't work, which you might expect to work. For instance, some people might think, well, I can use for each, right? So what I can do is I can take all the user IDs, right? I'm passing an array here, user IDs. And then I want to convert them into users, right? Kind of it's a for each, it's kind of like a map, but I wanted to start with a for each first. So what we create here, a user, basically that's our aggregator. And so what we do then is we await the user, right? Assuming that we're getting it from a database or somewhere. Here we're logging that we resolved it, just to help us a little bit understand what's going on. And then we push that user onto users, and then we return the users. And so, and then here basically we await that everything is done, right? So it kind of looks like that should work. I mean, we put async in front of everything. We're awaiting stuff. Should work. So who thinks that this doesn't work? Raise their hand now. I mean, it's kind of almost giving it away. By the way, if you raise your hand, you have to explain why not. Okay. I'm just going to keep going. I'm going to explain you guys why not. Here, it doesn't work. What happened? So we got an empty array back. And then it resolved stuff. That's kind of like returning. Remember, everyone who used callbacks would at some point return from a callback, right? and that never worked. So that's kind of the same story here. It's a little more complex though. What is actually happening? Well, we don't even need this await, because what we're actually doing is we're, for each ID, we're basically creating this async, we're basically creating a promise. But we're not awaiting it. We're just basically creating it here, right? From here to here, we're creating an async function, which basically is a promise, right? And then inside the function, yes, we await stuff, but we don't, but we jump here before we, before it's done. So that means that we return the empty users, and then these promises start resolving by themselves, and no one cares anymore at that point, because we can't get the values anymore. Now this await does nothing, because this await awaits the execution of for each, right? Well, for each isn't even async, but as I showed earlier, you can actually await even synchronous functions, and nothing bad happens. But so we are awaiting this, but for each creates these promises actually synchronously, and then returns, and then we're done. But we are not really done, because we actually hoped that the users would come back, but no, they don't, because we just created a bunch of promises, returned, and then the promises start resolving. Which is also kind of weird, right? Like promises starting to resolve just by themselves. Unfortunately, that's how it works. There have been complaints about it. Promises are basically not controllable. We'll see later that sometimes you may want to start them, or you may want to actually cancel them, but you can't. Promises are simpler. They are not like, for instance, C# tasks, which have more control. There was some proposal for cancelable promises. I don't know what happened to that proposal. Haven't heard about it in a while, but basically this is what we have to live with for now. So basically, once you create a promise, it will just start doing stuff just because you created it. So I hope that's clear. Now, since the for each didn't work, the map doesn't work either. So basically what we're doing here, again, I'm just going to prove this doesn't work. So basically, here we're mapping it. Actually, we can see a little bit better what's happening. So see this thing? I'm going to copy that out so we can put it in relation. So I'm going to put that here, right? Put it nice. Okay, so what's happening? We are calling map, right? We are awaiting map, but again, map is also a synchronous function. And yes, we're creating an asynchronous function inside the map, which becomes a promise. And so basically, we are mapping the user IDs to a bunch of promises that then later resolve. As we can see, they resolved at some point, right? But too late, because what we actually got returned to us were these promises. And thank you, Player Fine, for following me. Appreciate it. So we're returning basically a map of promises, or an array of promises, right? Because we mapped the IDs to promises. So with the map functions, it's actually more obvious to see them with the for each. And so these promises then start resolving, but by that time, we already forgot. Yes, Napcats, we are going to get to promise at all. Shooting ahead here, right? Yeah, so basically what I just wanted to show here, and promise at all is a little, we will see, we'll get to that in a little bit, because we're going to do sequential first, and then we're going to do parallel. But basically the idea here is that we're hitting the limits of async await. There are ideas where people think like, oh, but why don't we have an async map, right? And an async for each. And I don't know if that's going to be accepted or not, but basically right now we don't. So in this case, kind of how Napcast is pointing out, then we'll actually have to still interact with promises directly. So the idea is, and I haven't said that before, with async await, you kind of want to, you have to understand that you're using promises, especially if you want to debug things, right? And you want to understand what's going on, you want to understand what kind of performance overhead may I be creating. But in your code, you should kind of almost hide the fact that you're using promises. You want to stick to async await as much as you can, and using try-catch and all these things. And use promises only when you actually have to, absolutely. Because your code just looks nicer. You don't want to get, you want to mix and match this. You want to just stick to await, and whenever you have to use a promise, as we will see later, you want to await it immediately and get back into the async await mode. That's kind of the idea. That's my recommendation, my personal one, because then your code is kind of consistent, right? You're using async await everywhere where you can. So now let's get to how you can actually do. So in this case, we wanted to resolve one user at a time, right? First resolve this one ID, then resolve the other ID, then resolve the last ID. And how we could do this, obviously, we could just say, okay, we'll limit this to 3 IDs. And this is called sequential naive. It's the naive approach. And I just put this here because it makes it easier to understand the next steps. So what we do here, okay, so we'll resolve all these IDs basically to users, right? And then we return the array when we're done. So what's happening here is it's going to execute this task, and it's going to wait. It's not going to start executing the user2 task before user 1 is there, right? So this is what I mean by sequential. It's going to be one after the other. And so basically, and then we return the results. So this works really nice. By the way, this is a good time to bust out the debug thing that I added here. So I added a debug feature to our task thing, to our fake task. And what I'm basically using is, I'm using this awesome library, debug. So I'm going to paste it in the notes, which allows you really quickly to add debug statements to your code, but then you can basically selectively turn them on and off. So basically it says here task, right? And if you looked at the README, I'm explaining it there. So in order to actually have the debug statements show up, I now have to say I want to debug task. Otherwise they just won't show up. So I added a bunch of debug. So what I'm doing here is that whenever we create the promise, as I said, they're eager, so they kind of start executing immediately. So this, then I'm executing here. Now, if a task then gets rejected with an error, then I debug that. Otherwise, it gets resolved. So now we can basically watch what's happening under the hood, right? So let's go back. So as you can see, the default here is 10. It's waiting 10 milliseconds, right? So now we're going to run this with. So we're going to save it, and then we're going to say. Debug equals, and I think I already have that. So there you go. Debug is task, and then we run, so this %sign means we run the current file. So now we do that, and we get a little more information. So it's executing task 1, and then actually about 10 milliseconds later, it took a little longer here. It's not exact, right? Because it tries to just do it within 10 milliseconds, but it might be a little longer. Then it resolved it, and only after it resolved it did it even go and create the next task, right? So it basically was waiting in that function. Here, it didn't even get here until the first user was there. Now, as we'll see later, if I had another function that was doing other stuff, that could still run. But as long as I am in one function body and I have an await, it will not go to the next line until that await somehow completed, either resolved or it rejected, right? So, but hopefully most of you think this is kind of not the ideal way to do this, right? I mean, we're limiting ourselves to 3 arguments is kind of stupid. Well, it is. But it was easy to understand. So now we're going to do the non-naive approaches. So what we also can do is instead of for each, we can use for of. So for of is this new construct, very fairly new. Not to be confused with for in, for of. So for of basically allows you to iterate over anything that's iterable. So you can iterate over maps, you can iterate over sets. Don't get confused by, you can, you know, I don't know why the first example uses generators, but you can also iterate over generators because they're iterable, because each time you go, they yield another new value. But basically the idea is it can be an array, a set, a map, anything that's iterable. So it's a really nice way to write for loops, right? Instead of writing for I equals 0, blah, 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 we can just say for const ID of IDs. And that's almost pretty much like why you would want to use for each, right? Because you don't, it's writing this for loops by hand with the I is more error prone. You might make mistakes, usually one-off errors or something. Well, with for of, you don't. The other cool thing is we're not creating a new function here. When we use for each, right, we have to pass it a function. So we're not doing that here. It's just inside our function, which is kind of nice. And so then basically for each ID, we await it and make it convert it to user, and then we push that. And that should work, right? So there you go. So basically, and I'm going to run this with this. So we can see that it's working the same way it worked before. We're basically executing one after the other and waiting for the previous one to resolve. And then we go on to the next line, push it, and then we continue in the loop. So this works great. So again, this is where you can use synchronous control structures for asynchronous code. So you only have to run for of once, and you can use it for your synchronous code and for your asynchronous code. And then you see here what happens, right? this question: what happens if we don't await the task here? So what will we get an array of? And I'll give like a few seconds here to respond. Apparently I'm 30 seconds behind with everything, but just, you know, even if you don't have it in time, just think about like what we would return here, right? If we don't await it, what would be push here, and what would we have an array of? And obviously it's going to be promises. So here's a funny bit about it though, that these promises still resolve, right? But no one is there to listen. So basically we're executing the promises here, then we return these promises. So we create all the promises, we start executing, we return the array of promises, and we can't do anything with it unless we await them, obviously, one by one, but that wasn't the point. And then they still resolve, like they still do all the work for nothing, right? So that's kind of not cool. So you have to make sure every time you do this kind of stuff with a loop, you have to make sure you await each item and then push it onto another thing. And this would basically how you could be, you could wrap this algorithm and could create like kind of a map, right? So it should be fairly easy where you basically create this and you return that. And so basically you just say map, and then you allow me to pass in this part, right? You allow me to pass in the task, and now it will await the task for each item and resolve it to the item that I wanted. And so you can get creative with this and make your own helper methods. Now here I talked about how, you know, using var I equals blah 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 is a little error prone, but you can still do it. Sometimes it makes sense, especially if you want the, as we see later, if you need the index, right? If you need the I, then it still makes sense. So works the exact same way, returns an array of the resolved users. Any questions so far? Okay, and also feel free to ask questions even if I don't ask for the questions. Okay, same thing. This is getting a little bit boring almost, right? It's so freaking easy. Yeah, you just use while. Like, okay, you know how to use a while loop in synchronous code? Well, you just use the same way. Except you have to put in a wait. That's pretty much all, right? And obviously the task is an async or it's a promise or whatever. But it's really easy. And here what we're doing is we're just increasing I by 1 just to you know, have the while loop. It's almost like the same as that for loop, just written in a different way. But you can. And thank you very much for Kochi for following. So you can definitely use while loops. Now let's think about ordering. So what happens if the storm crow? Yes, I will. You can always go to my archive. So let me show you this. So if I go to my dashboard, if I go to my channel, where is it? So see these videos here? So you can always go there. I'm going to paste it in. So you can always see, okay, so now it actually, I don't know why I'm like streaming over here now. Could hear myself. So basically, here is where you can always find the most recent videos, and then I always also post them on my YouTube, which is youtube.com. So I'm just going to paste it as well. So you can just copy these links out, and then later on you can go there. So let me try to see where that is. My channel. And thank you for following, Eric. So here are my videos. And then usually I put them into playlists, but this should be view as subscriber. No, let's just do this. And who else followed me? The Storm Crowd. Thanks for following. So as I said, you can get the previous. You can see like the other episodes I did are here. Usually, if I have episodes that weren't that great, I don't export them to YouTube. But I'm obviously trying to make good ones. So usually they end up on YouTube. Okay, so we got the for loop. We got the while loop. Now we're going to look at ordering. Okay, so basically, does it matter how long they take? So what I'm doing here is I make the first ones take longer than the last ones. So basically here, if I is 0, right, my timeout will be 500, my wait, right? If I is 1, it will be 300. If I is 2, it will be 100, right? Hope that makes sense because, yeah. So now, you know, some might be thinking, well, maybe then it orders them in another order, but it does not. We could see it took a little longer because of the timeout, but here we can kind of see what's happening. So it did the first one, right, and resolved it, and it waited till it resolved. It didn't even do anything else before that. And then it went to the next one. That one was a little faster, right? and then it went to the next one and did that. And then obviously, since we were pushing it in that order that we receive it, it ends up in that order. And that's all, fairly obvious in this case, but we're going now to the parallel one. And so we're also going to look if in the parallel version, it's also going to do it this way. Now, we're going to get to, I hope Napcat is still with us. We're going to get to promise.all. So basically, let's just say we have like a bunch of users and we have to make a bunch of database calls, right? Or let's just say the user's friends, right? So like we want to find information about all the user's friends. And obviously, having to wait, like basically how we did it, let's look at the naive one because it's easier to understand. Having to wait, do one user at a time is kind of not very efficient, right? So basically that would mean our process wouldn't be any busier or anything. It wouldn't like our node process wouldn't become any slower. Like it could still handle the same load because we're not, as I said, we're not really blocking the event loop. But the latency, no problem, Napcats. I'm always happy if people actually like already guessed what I'm about to say, because that means I kind of got it right, talking about the right things. So basically, what means that the latency increases, right? Because now let's say it takes me 200 milliseconds. Well, that's a little extreme, but let's say it takes 50 milliseconds per user, or per user friend in that case, to get that, right? Now that means I would take 150 milliseconds at a minimum to get them all, which means the latency would be 150 milliseconds at a minimum. What if I could kick them off in parallel though, right? And then each one takes 50 milliseconds. So let's say kind of, one's a little slower, blah, blah, blah. I might come back to a total of 60 milliseconds. Now, obviously, my latency just went down more than 50%, right? So that's cool. That's why sometimes you want to do things in parallel. However, there's no way to say async parallel or anything like that. You can't just say, I want to do this in parallel with async. In that case, you still have to go back to using promise functions. As I said, any async function, which our task is an async function, right? What it does when you call it, well, in this case, actually creates a promise manually, right? But even this function here creates a promise also. That means we can just use promise functions that work with promises as inputs, and we can use them. So promise.all, what it does, it takes an array of promises. User 1, user 2, user 3 are all our promises, right? And then it will wait for all of them to resolve, right? All of them. And only once all of them have resolved, it will resolve itself, which means if we await, so basically when we return this, right, here, it just returns us a new promise. And that promise will resolve itself once all the promises that we pass to it are resolved. That's when it resolves. So that means we basically get all the users. So let's do that, and we got all the users. Cool thing is they're all in order. Well, that makes sense because we call it in order, so maybe that's why, right? But we'll see if that also works in other cases. What happens if a promise rejects in there? Well, let's try it, right? So all we have to do is you pass an error. Boom. Right? So let's pass an error here and see what happens now. So now we have an unhandled promise rejection. Oh, what happened? Oh my God. Well, it's because we didn't put any try catch. So Node still kind of figures out there was some rejection that you didn't handle correctly. So, and by the way, don't do that in the future because then we'll just kill your process. So what we can do though is we can put a try catch anywhere. We can put it. We could put it around here, right? Or we can even put it out here. So we put a try catch here. So this is the cool thing, right? It doesn't matter. Like as long as we have some try catch somewhere, it'll be fine. Imagine to do that with callbacks or even with promises. It's much harder because with promises, at least we'd have to attach it here somewhere. With callbacks, it's even more tricky. So now let's see what happens. Okay, cool. We got boom. We see what happened on timeout. So now we could go here and see what happened. Or let's just npm. Let's just use Budo and figure out what actually happened. Right? Which one is this? This is number 10. So switch to the browser. We're here. Let's turn uncode exceptions on. Oh, look, right away where it happened, we see it. I mean, this is awesome for debuggability. We can see okay, so we created a new promise here. Why did we create it? Well, because here, you can see this caused the error. Amazing. I mean, anyone who's done callback-based development will know that it's much harder. I mean, I was also a big proponent of callbacks because if you write clean code, you can still work with callbacks. It works, but this makes it so much easier. So you see, if any of the promises that we pass to promise at all somehow rejects, the whole promise will also reject. So it's a very nice way. But you see here that we just do one line and immediately we go back to await. We don't. What you also could do, you could say, it's not just because now you're in promise line, you could say then, right? Because now you see, oh wow, even I get the IntelliSense. So if you're like using VS Code, it gives good. My Vim also gives me good IntelliSense. Oh wow, maybe I should use .then. No, don't use that. Just go back to async await as soon as you can. That's the idea, right? Okay, cool. Now we're going to look at any questions. I need to ask questions so I have a time to drink my Coke. By the way, Colombian Coke so much better than American Coke because you use real sugar. So if you ever in Central America, make sure to drink the Coke, or in South America. Okay. Now let's look at how we could do this a little better, right? This was a naive version. Again, this only works with like 3 user IDs. So we can actually map things. Because, right, we saw earlier that if we mapped something, right, we couldn't like await it directly, right? Because what did it do? Well, it mapped values, in this case IDs, to promises that hadn't been resolved yet, right? Well, what we can then do, since it's promises now, I call them tasks, but they are promises, we can pass those to promise at all. Look at that. It just worked. And let's see the with a little debugging turn on. So we can see that they all start executing right away. So basically, once we, right, when we call the map, right here, when we call this function, under the hood it creates a promise. That's when they kind of start executing because, as I said, they're eager. And then, so then we have these promises hanging around, and then they start resolving whenever they can. And since we are, since we pass them to promise at all, we've wrapped them in another promise, and we awaited the promise. Now we actually get the values out. Okay. Now about ordering. This is like actually one of the funner part. So it's executing in parallel, right? Like, I mean, so how do the values come back, right? How do we know which is which? Like, we pass in the first ID, second ID, right? How do we know that the user, the first user in the array is actually the one for the first ID? We don't know. Well, let's run a little test. This is kind of the same idea that I did earlier, except it was with sequential code. So what I'm doing here is so for those who don't know, if you call map, the first value is always the value that was in the array, and the second value that's passed to that function is actually the index that value has in that array. So we're using that fact to then create a timeout. That's different for each of them. So basically, for the first item is index is 0, so then the delay will be 500, right? And so on. For the second one, it will be 300, and for the third one, it will be 1. So basically, the first one will take the longest, yes, and the last one will be the fastest. So that would mean that if they were ordered in the way they come back, we would have it reversed. Make sense? Yeah, I hope so. So if I run that, though, we can see that, well, they are actually perfectly in order. Okay, so let's verify that they actually are resolved in opposite order. So let's see what happens here. We're executing, so when we basically create, do the map again, it executes the promises right away, eager. But then actually the resolving happens in the opposite order, right? We can see that Bob 3 was actually resolved before Bob 2 and even before Bob 1. But we can still see that we also got the right order of things. So what does it mean? Promise at all, magic. It orders it for us. So basically under the hood, it does all these things, it waits till they all resolve, but it keeps track of which is which. And then the array that it returns us is in order. So that's pretty awesome. So that's how you would do a parallel execution. So again, just to recap, if you have an array of items that you need to process, think about if they depend on each other, right? If they are totally independent of each other, like if I can get this friend and that friend and that friend, and I don't have to, I don't have to pass in the first friend to get the second friend, use promise at all. If, yeah, well, yeah, but Napcats with async await, it's even better. So you get the magic when you need it from the promises, because there's still promises under the hood, and then you get much better syntax as well. So now for sequential, so here, for instance, it didn't make sense to have the sequential, right? Because they didn't depend on each other. But let's just say, so the first user, right, is this, and then we say that the next. So let's just rewrite something here. Let's just say the last user here, right? And so we say the last user is this one, and last user is this one, right? And now basically what I do is, instead of say, let's just say this is a parent of this. So we say that the parent, so it's null, right? So let's say then we say that the parent of this dude is the last user. Make sense? And then we do this in circles, and then basically Bob 0 or the Bob 1 will be the parent of Bob whatever. We'll print it out and we'll see. So here you can see that Bob 1 is the parent of Bob 2, and Bob 2 is the parent of Bob 3. And obviously, in order to do that, we needed to have Bob 1 first before we could figure out the parent of Bob 2. Does that make sense? Okay. So that's when you would do a sequential, right? But basically, you have dependent tasks on each other. This also makes sense, obviously, if you do this, even if this task was entirely different, but if you're doing one at a time, and each time you need the result of the previous one to do the next one, that's when you would do sequential execution. And also, I guess you would do it if you're not too concerned about latency. If you're using, if you're writing a script, for instance, right, and using read file, and it's just like a command line script, and it can't even be finished anyways till it's finished. So you might make it a little faster by using parallel, but you might not have to. Okay, any question? Because that's kind of tricky. I understand when to use parallel and when to use sequential. Okay, but again, for parallel, you have to use promise at all. For sequential, you get to use synchronous data structures. So now let's look at another thing. So what if I, so in this case, friends, we're using friends. What if I only needed one friend of Bob? And I call out to 3 different services to find that out, and I don't know which one is faster. So then I can use promise.race. So race basically kind of means what it does. Like they're all racing to complete, but whichever promise returns first will be used. So instead of resolving all of them, or waiting for all of them to resolve, it just returns already when the first one resolved. So here we get Bob 1, right? Because Bob 1 was just first, so that's why it was faster. So we just get one result. Out of even though we have 3 users, we just get one result. Now, let's look what's happening on the hood, though. What? Why is it still resolving all these other things? I mean, we already had Bob 1, right? So why is it still resolving Bob 2 and Bob 3? Well, that's a disadvantage of promises. They're eager. Once you kick them off, they're kicked off. They're going to do what they're going to do. Even if you say, I don't need this anymore. I have Bob 1. Like, stop doing Bob 2. Stop wasting my resources. Stop wasting, the internet. It doesn't do that. Promises will still resolve once or reject once you get kicked off. You cannot say stop. It doesn't work. So that's kind of the downside there. So if you use race, don't use it like with 300,000 things. If you're only interested in one, it might actually be making you slower and definitely use more resources, right? So that's what, and again, that's also a thing that you can't do just with async await, which is why we're using promise.race here. So that's kind of what that does. Any questions there? So now a good question would be, what happens if I have an error in the middle, right? What happens if so the funny thing is, we saw that Bob 1 resolved, right? And then was done. But what happens if Bob 2 rejects? But I mean, we didn't even care, right? Well, let's see. And I actually didn't try this yet, so this is going to be a surprise for me too. So, so basically, so if ID is 2, we say boom, and otherwise we just, the error is null, and in that case it will resolve fine. So we pass the error here. Now let's see what happens. I'm kind of excited. Anyone want to take a guess? Napcat, maybe you know these things? Oh, look, we got an unheld promise exception. So let's Let's load this into Budo and play around with it a little bit. 13. All right, and what we'll do, we'll keep the both null exceptions on. Okay, so it rejected here. So it was created here. That's correct. We create the promise and then a timeout. So what if it, so let's do one thing. What if we set the wait really high to make sure that it doesn't even resolve until much later? Wait, let's do that 200. The other ones have 10, right? So let's see what happens then. Cool thing is now with Budo, I just have to refresh. That's like the disadvantage with debugging with node inspect, because then the program will always finish. You have to restart it. With this one, you can just keep going. So what happened here? We got the users. So it should have already. See, the funny thing is then it didn't. That's really funny. So it didn't return to us yet. It's actually really interesting. So here's the timeout. Here we reject it here. It sets a timeout. So let's actually, we set the wait correctly. It's fine. So basically, even it didn't give. So even before, so let's set it to much higher. Let's make it blow up in like 10,000 seconds. 10 seconds, not 10,000. Well, let's do 5. That's fine. So let's do 5. And at that point, I would expect it to already have returned, right? Like it should already have printed something. So let's do that. What's happening now? Oh, okay, now. Okay, so do you see that it didn't print anything yet? Right? So it printed undefined users. So basically, the users were not resolved properly. And then in our call stack here is basically that error. So basically, if one of them of your raise things throws, you're totally screwed. It seems like you're not getting anything back. And that's definitely a promise wait thing. That has nothing to do with async await. So then again, be careful like with the raising, right? If you raise a bunch of things and one of them throws, you need to make sure that you ignore that. So you need to make sure that whatever promise you pass in, so let's see where do we have that. So whatever promise you pass in here, right? Here, you would have to make sure that that task itself has a try catch around it, so that you catch that error, you log it, but you know, as long as you get at least one back, you're fine. So that's how we could fix it. Let's actually just do that since that's kind of interesting. So what we'll do is we'll put a try catch here. Oh, let's see how that works. So we could put a thing here. Yeah, I think, well, we are not awaiting anything here yet. What we could do, we could make this in a promise that wraps this, and then we can try catch in here. And then we console log the error. And now we should actually be fine, because now, oh, because they're all waiting 5,000 seconds. Okay, commando, change of commando. Right, so basically if the ID is 2, then we do 5,000. Otherwise, we do 10. By the way, if you see me making mistakes, let me know. I'll be more than happy. So, so let's see what happens now. So we got undefined back. I'm not entirely sure why we get undefined back. Oh, because, well, we're not returning anything from here. So this is tricky because this used to be an expression, right? And then we basically changed it to a full-blown function body to put all the stuff in, and then in an expression you don't, okay, so is this how it works? So you still get something back, and then you blow up. And then it doesn't care anymore, look at that. So then it doesn't care anymore. So what I said earlier was all wrong. So if you do raise, it seems to be just looking for one of them to complete fine. If any of them reject, it will just be fine too, because it will just ignore that. That's actually pretty cool if you think about it. So let's try this again. So basically I already got my result back. I'm still waiting for these other to resolve. So basically but I don't care anymore at this point. And then if they blow up, they blow up. Okay, that's fine. We can live with that. That's a cool feature. Okay, any questions so far? This was like also kind of a lot, especially since I got confused a little bit. Thank you, Baltic, for following. Appreciate it. So no questions. All right. So again, in summary, if you're interested in executing a bunch of things in parallel and you want all of them, use promise.all. If you kind of only need one result, but you don't know where it's going to come from quicker, you can use arrays, promise.arrays, and whenever the first one resolves, fine, that's going to be a result. It will ignore all the other ones resolving, and it will even ignore if one of them rejects. So let's let's run this, and so you can kind of see what's going on. So we executed all three of them, resolved the first one, right? Resolved the first one, and then we already have our result. And the only reason why we're stuck is because the node process doesn't exit. We are not really, so actually let's make that clear. When we console log users, we are done. We're not waiting anymore, right? The only reason why we're not exiting is because node process realizes there are still some promises that haven't resolved or rejected yet, so I need to wait. So that's why we're still running, but we're pretty much done. So what we could, for instance, do, we could be brutal and say, just exit, I'm done. You shouldn't do that in your library, but see how quick that was? Because we forced the process to exit. But in this case, we're waiting, and because there are still promises, and then you can see that one, the second one also resolves after 10 milliseconds, and then the last one rejects after 5 seconds. So, but at that point, we don't care anymore, and then it doesn't even cause an error, so that's fine. Okay, let's move on to conditionals. Cool thing is, that's actually really simple. As with for loops and for off loops and all this stuff, conditionals also work the same way as they work for synchronous code. So we don't have to learn anything new. And this was especially hard. Oh, one thing I wanted to mention before we go on, one thing. Where did I do this? Where did I do the parent thing? In the naive sequential, right? No. Where did I do the parent? I can't remember anymore. But you guys remember where I did the parent thing, right? So the cool thing is that when I'm trying to do user 2, I have access to user 1 just because I'm in the same function scope, right? Now, in callbacks and so on, that was never the case. And I also have access to all the IDs. Like, we didn't change function scope. All the variables are in scope. Everything that I need is in scope. That's why sometimes you ended up with nested promises because you needed to access a variable in a certain scope that you wouldn't be in if you were just chaining the promises normally. So none of that pain happens with the async wait because you have everything that's in the scope. So now let's go on to conditionals. Really, really easy. So here I'm saying if the ID is 2, for whatever reason, I also want to add the age for the user. So this is how easy it is. Boom, done. It only added the age for user 2 because I'm using synchronous flow control, synchronous basically constructs. It's really easy. Like everything you already know, you can apply. The only difference was I put a wait here. And it looks like synchronous, right? Really easy to understand. One thing you should make sure that in your code, in your editor, you can see, like for me, they're a really distinct color, async and await. Make sure your editor has that feature too, so you can easily spot them, right? So you're not getting confused. You're thinking you're reading something synchronous, but it's actually asynchronous. Like a lot of people complain about that it makes code look synchronous, but it's really not. Well, I mean, it's pretty clear. There's no wait right here. So easier to see though if you have these colors, right? So here's the thing. So I kept saying that it blocks in the function, but it doesn't really block the event loop. Well, what does that mean? Well, here we have an example. Basically, we have the same function 3 times. And all of these functions go and get the users, like lots of them, like 3 each time. And then basically, so they're setting when they say when they start. then they basically get stuck here, right? They're waiting. And then they log when they're done. But when I say they get stuck here, that doesn't really mean that the event loop in your browser or in Node is stuck. The event loop is still spinning. Well, because if it wasn't, if I set that timeout and it fires, right? Once that other timeout fires, it couldn't run. Is that correct, right? I mean, if the event loop was stuck, it couldn't handle that other timeout firing. It wouldn't be able to call get batch DOS until, just by the way, because I'm in Colombia, they're called get batch uno, get batch DOS, and get batch tres. So anyways, like if I was really stuck here, we couldn't even enter this function, right? Because the event loop is stuck, right? Well, but the thing is, it's not stuck. So we see it in a second. So we see getting batch uno, DOS, and tres happens like immediately. But the thing is that this one waits longer. Actually, let's run it with the. So what's happening here? So we say getting batch uno, right? It starts executing that task for batch uno, and now it's waiting, right? I'm gonna make this with a waiting. Okay, not really waiting. It's actually just looks like waiting. It's not waiting. It makes it. What it does, it says, oh. I was here in this function, so let's put it here. So it says, here I was in this function. I just launched an asynchronous task in a promise. I'm going to remember where to continue once the promise resolves. That's what's really going on under the hood. To you, it looks like it's waiting. To you, it makes your life a lot easier because that makes it easier to think about your code program. But in reality, it just remembers that spot. And once the promise resolves, the event loop is spinning, right? So event loop spinning like this. Then basically your promise at some point, you kicked off the promise here, the event loop keeps spinning, it can do other stuff now. And then your event loop actually resolves, and then it says, okay, it resolved now, where do I need to continue? And it jumps right to your function right here, and it continues there. That's basically what's happening under the hood. So that means you're not really blocking. It just makes your code look like it's executing synchronous because that's easier to reason about everything. So let's look at the log again. So basically what's happening, we're getting batch uno, we execute the promise, and then we're waiting, but we're not really waiting, because now immediately so basically what's happening again, right? We kicked off getting batch uno, it's executing the promise, but it's not blocking, it keeps spinning. Now the batch DOS timer fires. It says, okay, where's that function? It calls your getting batch DOS function. And so now we kind of are here saying getting batch DOS here, right here, and then we're executing. Well, you can't see my screen, sorry. we are getting batch DOS, we're executing. So let me actually put that. So getting batch DOS, right, and we're executing. And then the event loop keeps spinning, and then the get batch stress timer actually fires. Then we execute batch stress, right? And now they all start resolving. But the event loop was spinning. It was just spinning and waiting for them to resolve. It wasn't stuck. And then whenever the first one resolved, in this case it was actually Bob1 resolved, then it's like, okay, so Bob1 resolved. Let's see what happens. Well, okay, Bob1 was basically initiated there, so it knows where to go back to. And then it continues here. It goes to the end of a function, and boom, it's back in the event loop, right? And then it says, okay, now, let's see, Bob2 resolved at some point at least, right? So so basically when Bob1 resolved here, right? Then actually Bob4 resolved. Okay, so it dropped into that function, continued, and then continued the event loop. So, and then basically it started executing Bob2. So you see, like, there's still things going on the whole time. So unlike with real synchronous code, if you have an await there, it's not really stuck in that function until it exits the function. So that's the case with async. So if I wouldn't put this here, it would basically not be able to do anything else until I exit the function. However, an await statement basically allows it kind of to postpone execution of that function and continue where it left off when it's done. So that's kind of really important to understand. I'm just seeing this now in Napcast, by the way. Maybe you could return empty promise and catch. Yeah, that's kind of what I was thinking, right? But then we found out that that we were wrong, that it's already basically doing that. It just doesn't, it ignores the problems, right? Okay. Any questions about that? That's really important to understand, that it looks like you're blocking, but you're not really blocking the event loop. You just basically say, I was here, continue on the next line, whenever you're done. That's basically what it means. But the thing is that in the meantime, it starts doing other stuff. Okay. So it's kind of like, it's like a callback with a lot of syntactic sugar. Okay, now we're going to get into a little bit of things to maybe not do so much. So basically, you don't want to nest weights like too deeply. You want to have clean code. The reason is it gets harder to debug and understand the stack trace it, and it also may add a performance overhead. Obviously, if you nest deeply, right? So basically, if you have your outer weight here, and that depends on the other weight completing, and that depends on another one, another one, another one. Now all of these here, right, have to basically stay in memory and have that overhead until all of them, so basically at least the inner one resolves, and then they can all resolve. So you're creating like memory overhead. And if you create too much of it, well, as we see in the next example, you will actually drive the garbage collector crazy, and that will hurt your performance. So, but let's look at this a little bit here. What we'll be doing, I tried to come up with a good example, but it was really hard. This is a little bit contrived. So basically what you're saying, when we get the user, we say actually maybe get the user, because what we're first going to check is if the